Its heart can beat more than 1,200 times in a single minute, a pace closer to a struck tuning fork than anything else with a pulse. That speed isn't a party trick. A hummingbird's flight muscles demand oxygen faster than almost any other tissue in the animal kingdom can burn it. And the only way to deliver that much fuel is a heart working at a rate most other birds would never survive sustaining for more than seconds. Wing beats follow the same logic. Some species rotate their wings in a figure eight, rather than a simple flap, generating lift on both the upstroke and the downstroke, which is the only reason hovering motionless in open air, or flying backward, is even mechanically possible for a bird this size. That wing motion alone can cycle dozens of times a second in ordinary flight. And during certain display dives, some species push their wing beats even faster still. The blur it creates in open air. The only visible trace of a muscle contraction, happening faster than most eyes can separately register. None of that output comes free. Running a body this hot, this fast, burns through stored energy in minutes, rather than hours. So a hummingbird has to feed roughly every 10 to 15 minutes through daylight, or risk running its own fuel tank dry, mid-flight. That single constraint reshapes everything else about how it survives contact with the world around it. A patch of flowering plants isn't scenery. It's the only thing standing between a hummingbird and starvation measured in tens of minutes. Which is exactly why a bird a few grams in weight will attack rivals many times its size over control of one blooming shrub, an aggression that looks disproportionate until the actual stakes of losing that patch are counted. Over the course of a single day, that same bird may visit hundreds, sometimes well over 1,000 individual flowers. Each stop lasting only a second or two before it moves to the next, an entire day built around a feeding schedule that leaves almost no margin for a storm, a competitor, or a single blocked flower patch to disrupt. Feeding itself runs on a mechanism almost nobody would guess by looking at the beak alone. The tongue extends far past the tip of the bill, forked and fringed, drawing nectar upward through a rapid, elastic pumping action rather than simple suction, retracting afterward into a channel that curls back around the skull when not in use. Night breaks that entire system. On purpose. With no flowers to visit in the dark, and fuel reserves too small to burn at full metabolic rate for 8 straight hours. A hummingbird can drop its body temperature and heart rate dramatically, entering a state of torpor that cuts its energy use by a wide margin compared to daytime activity. It is, functionally, close to shutting itself down, waking each morning from something nearer to suspended animation than ordinary sleep. That drop has to be timed with real precision. Entering torpor too early wastes daylight foraging hours that could have added more fuel to the reserve, while waking too slowly at dawn risks a body still too cold to generate the wing beats needed to reach the first flower of the morning. Before that stored fuel runs out entirely. That same fuel storage system, built to survive one long night, becomes the foundation for something far more extreme once migration season arrives. Certain populations put on nearly double their normal body weight in fat before setting out, then cross open water for roughly 18 to 22 hours, without a single place to land, rest, or feed along the way. The same metabolic machine that nearly stops each night to save fuel is the exact machine now expected to run continuously for the better part of a full day over open ocean. There is no torpor available out over that water, and no flour waiting halfway across to top off the tank. Every gram of fat stored on the days before departure has to last the entire crossing. And a bird that misjudged its own reserves even slightly has no fallback option once land disappears behind it, and only open water remains in every direction ahead. A bird built around 10-minute fuel stops is asking that same body, unmodified, to run for the better part of a full day, with nothing beneath it but water in every direction. No flower petal in sight, until land finally reappears on the far side. It will do this again tomorrow, and every day after, for as long as there is anything left blooming to feed it.